Good morning. Welcome to the discussion of the concept of the probability. The first word on probability. So, what do you mean by the probability? Probability is similar to the concept of percentage, wherein probability of an event is the measure of the chance that event will occur as a result of experiment. That is, if we are going to consider an example, only difference here is we are not going to say that something is in percentage, the chance of case in probability if it is 50%, if it is in the case of the probability we say that it has a zero point 0.5. Probability is the numbers between 0 and 1. If the event is having the probability that is p is equal to 0, it is called an impossible event. If the event is having that p is equal to 1, then it is a sure event. Sum of all probabilities in particular situation is summation of p is equal to 1. And the terminology is experiment. Experiment is nothing but activity with an observable results. Next comes the trials, that is repetition of the experiment is called as trials. Next, outcomes, results of each trial. Sample space, the set of all possible outcomes. The sample points, elements of the sample space. Event, subset of the sample space is called as event. Now in next we are going to discuss the sample space in detail. The set of all possible outcomes of a random trial, like tossing of a coin, choosing the winning number in a lottery, where each outcome has same likelihood of occurrence, such a set is called sample space of the trial. Next we'll move on to the event, subset of sample space consisting of the favorable outcomes in some specified sense is called as event. Suppose if you consider S is a non-empty finite sample space of the event A, then the number of probability of A is equal to sample space event A divided by sample space is called the probability that A occurs within the probability of A. The characteristic features of a random trial is all outcomes of the trial have been the same likelihood of occurrence. Thus, tossing of coin is taken as a random trial only if the head and tail have equal chance of occurrence. If a coin is likely to show more heads than tails when it is tossed several times, its tossing is not taken as a random trial. The example we are going to mainly consider with respect to event is a flipping of a coin which has tendency to show more heads than tails or vice versa is called biased coin. An unbiased coin is called a honest coin. As indicated by event A, that is with respect to the flipping of coin, we mean that set of all favorable outcomes in some specified sense a random trial. This subset of the same sample space S, wherein each element of an event is called as elementary event. Next comes the probability formula, wherein we are going to define that n of A is number of elements, n of S is number of elements in S. So probability of formula is defined as P of A is equal to n of A divided by n of S. This formula mainly holds good whenever there is a valid sample points and which are equally likely. Next we are going to consider the problem, that is flipping of a coin 3 times. We are going to flip a coin 3 times and we are going to initially find out the sample space, wherein we are going to get the sample space in the form of heads and tails are the two faces of the coin. Now the sample space we are going to find out is heads, 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 next heads, head, tail, next is head, tail, head, next is tail, head, head, next is head, tail, tail, next is tail, head, tail, next is tail, tail, head, next is tail, tail, tail. So this basically forms the sample space. From this sample space obtained, we can find out the event. That is, if the event A that is given is getting exactly 2 heads, we need to categorize that with respect to event A. That is, once you flip the coin, how many times exactly you are going to get the 2 heads. That is, event A is equal to head, head, tail, head, tail, head, tail, head, head. These are the three possibilities of getting exactly two heads. Next is a problem with respect to the bag of marbles, wherein it contains 4 red and 6 black marbles. What is the probability of red marble when we try to pick without looking at it? Solution, how you are going to find out is nothing but you are going to collectively find out how many marbles are there. That is 4 red marbles plus 6 black marbles is equal to 10 marbles in total. Here the probability is with respect to finding out the red marbles. So P of red is equal to number of red marbles divided by total number of marbles. P of red is equal to 4 divided by 10 is equal to 0.4. So 0.4 is the probability of getting red marbles without looking at the bag. Next comes the addition rule or addition theorem with respect to the probability. Suppose A and B are two events in sample space, then A union B is an event in S consisting of outcomes that are in both A or B or both, and A intersection B is an event in S consisting of outcomes that are common to A and B. According to the principle of addition, A union B is equal to A plus B minus A intersection B. After modification, it yields with probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This is called addition theorem of the probability. Next comes the mutually exclusive events. Two events A and B in a sample space are said to be mutually exclusive if A intersection B is equal to null. Then probability of A intersection B is equal to 0. So that then in the next step, addition theorem reduces to PR of A union B is equal to, that is probability of A union B is equal to probability of A plus probability of B. The following is the generalization of the results. That is, we can generalize the union along with the probability of the results. Thank you. For any queries, contact at gaurav.vr14@gmail.com.